Imagine this scenario. You go to bank 1 and your friend goes to bank 2. Both of you deposit the same amount of money, 1000 rupees, at an interest of 10% per year, which is pretty high, but just for the sake of this argument, let's keep it. At the end of 1 year, you have 1100 rupees in your bank, which means you earn an interest of 100 rupees. But now your friend has 1102.5 rupees. How is that possible? Both of you deposited the same amount of money and at the same rate of interest. But your friend has more money than you. That's very interesting. Why would you not do that? Why would you not deposit it in the bank too? Let's understand what Bank 2 does differently. What Bank 2 does is known as semi-annual compounding. So what is semi-annual compounding? It is the idea where interest is added to your principal twice a year instead of just once. And that actually gives you a slight bit of more interest overall than adding it just once a year. Let's understand it mathematically as well. In a 1 year timeline, this is what would happen. So you deposit the money in January and you get the first deposit in July. And this is the case of semi-annual compounding, where you get interest twice a year. Again, get another interest in December. So you're getting compounding twice in the same year. So each time interest is added to your principal, it's called a conversion period. In semi-annual compounding, you will have 2 conversion periods per year. So let's understand the conversion period. It is the time interval after which interest is added to your principal. For example, in annual compounding, when you first deposit the money in January, you get the money in December with interest. So it's only one conversion period. The overall number of conversions is just one. So you get interest added only once a year in a period of 1 year or 12 months. So in 12 months, your money is compounded only once with whatever rate of interest you have given to the bank. Now, in the case of semi-annual compounding, what happens is the money gets compounded twice. So you have 2 conversion periods. So you deposit it in January, your first conversion happens, or the first interest gets added in June. And again, another interest gets added in December. So you have 2 conversion periods. So here, this is one conversion period, another one over here. So total is 2 conversion periods. So this double conversion periods is known as semi-annual compounding, where you get interest twice in a year. And that gives you a slight increase in the overall amount. More frequent conversion periods means faster growth of your money. So how does the formula change for semi-annual compounding? For annual compounding, this is the formula that we have studied, which is A, the total amount, equals the principal times 1 plus the rate of interest and the overall tenure, which is the number of years, n. For semi-annual compounding, this is how we need to change the formula. So step 1 is we divide the annual rate by 2 for each period. So we take the annual rate, which is R, and we divide that by 2 to get a R by 2. Next, we multiply the number of years by 2 to get total periods. Because each conversion period is a different period, right? So we multiply the total number of years by 2. So if we have n years, we multiply it by 2 to get 2n in the case of semi-annual compounding. So if you plug this in, we get semi-annual compounding is A equals P into 1 plus R by 2 whole to the power of 2n. That is the formula we get for semi-annual compounding. Well, let's try some examples. So first, calculate compound interest on 1000 for 1 year at 10% per annum, compounded semi-annually. Always read the question properly. So first step, principal P, we identify each of our given numbers, which is first is principal, which is P, 1000. We have R is 10%, and then we have N is 1 year. So now the compounding is 2 periods. It is semi-annual. So what do we do first? We divide the annual rate, or we can directly apply the formula as well. So A equals P into 1 plus R by 2 whole to the power of 2n. So substitute values in. So P is 1000, R is 10%, and N is 1 year. So 2 into 1. So what do we get? So we get 1000 times 1 plus 0.05 whole to the power of 2. So 1000 plus 1.05 whole square, which is 1000 times 1.1025, which would be 1102.5 rupees. So the compound interest would be CI equals the amount minus the principal. which would give you 1102.5 minus 1000, which is 102.5 rupees. And that's what we were asked to calculate. Let's take another example. Find the compound interest on 5,000 for 2 years at 8% per annum compounded semi-annually. Let's try this. So again, principal is 5,000 rupees, annual rate is 8%, time is 2 years here. Careful to see that. It's 2 years here, and compounding is semi-annual. So what do? The formula is A equals P into 1 plus R by 2 whole to the power of 2n. So P is 5,000, R is 8%, and N is 2. So now we calculate 5,000 times 1 plus 0.04 whole to the power of 4, which is 2 times 2. So 5,000 times 1.04 whole to the power of 4. So 5,000 times, if we need a calculator for this, 1.16986. You will not be able to do it. Even if you try to do it in the exam, it's going to take a while, but yeah, try to do it manually. So A equals 5,849.29 rupees. So the compound interest would be A minus P, which would be 5,849.29 minus 5,000, which would give you 849.29 rupees of compound interest in 2 years. Now let's take a quick comparison to get a final understanding of why the semi-annual compounding is better, like we did in the beginning when we visited 2 banks. So annual compounding, we have A equals P into 1 plus R whole to the power n. So in example, we take 5,000 for 2 years at 8% interest. So we calculate this to come out to, the compound interest is coming out to 832 rupees. But in the case of semi-annual compounding with the same parameters at 5,000 in 2 years, 8%, we will get 849.29 rupees. As you can see, this is around 17.29 rupees greater. If your amount is big, you will actually make much bigger difference. But most banks in the world only offer annual and not semi-annual, which is unfortunate. And here's a bonus question for you. Calculate the compounding interest on 8,000 for 3 years at 6% per annum compounded semi-annually. Alright, I hope you had a good time understanding semi-annual compounding. I'll see you next time.